All right, everybody. Welcome to Intro to Object-Oriented Programming, Day 1. This is an exciting time for me. This is our first 100% virtual course, and I'm looking forward to some real video shenanigans with you this season of lunch learning. So as you are watching, please get on Teams and introduce yourself. Because we don't have any face-to-face time, it's a little harder for me to get to know you and thus to help you. So I would prompt you to please be active on Teams. At this time, I just ask that you pause the video and get onto the Teams channel and introduce yourself. Answer several questions like, what department are you coming from? How long have you been at the company? And what you hope to gain from this course? Or what are you going to do with your programming skills? So please get on, be active on Teams. Reach out to Eric or myself or to the channel at any time. Okay, as stated, when you signed up for this course, there are several prerequisites, okay? I'm assuming that anyone watching this video has already taken Intro to C# here at Health Equity with me, or they already have some C# knowledge. We won't be covering basics like logic and loops. I'm assuming that you know that already, okay? We'll also use Visual Studio Code and the .NET Core 2.2 or higher SDK. Those things you can find a link to for download on the wiki. And if you're not an admin on your machine, you will need the service desk's help to install that, okay? So this is a very high-level description of what this course will cover, okay? We're going to learn object-oriented programming, and that means classes and objects and the fundamentals of object-oriented programming like inheritance, polymorphism, encapsulation, and abstraction. And those words are probably gobbledygook for you right now, but they will become meaningful hopefully by the end of the course, okay? Not only are we going to learn all of these principles, we're also going to build an app. It will be a console application that, if it's good enough, it will assist the Culture Club in signing the entire company up for movie night. It's quite the task to do that, and we're going to learn so much and be able to empower the Culture Club with our app. And every day I hope that in addition to some lecture, you'll get a chance to write some code. Okay, this is the first ever 100% virtual course that I know of at the Health Equity Lunch Learning, okay? We're virtual this time around because we've got some conflicts with scheduling rooms. And also I'd love to try out the virtual environment. So because we are virtual, we can have an unlimited class size, okay? You will still get lunch. Please know that. If you didn't get lunch today, you should have. And contact myself and we will get you some lunch, okay? Another thing to consider is many who are at Health Equity who want to attend these courses are in the call center and can't get VTO during the traditional lunch hour. So we're able to reach out to those folks. Okay, in addition, classes will always be recorded and uploaded to YouTube, so you can watch and rewatch them at your convenience, really. Okay, but a huge challenge I see in front of us is that we aren't going to have much face-to-face time, okay? You're always welcome to come down to my desk and ask questions. You're always welcome to email me or message me, but the feedback cycle of asking questions, trying it out, and receiving feedback on your results is going to be a lot slower because we're virtual, okay? So again, please be active on Teams or email or come down and see us. Myself and Eric Tang are here to help and serve you. Please reach out. Okay, that's a little bit about the course. Now a little bit about the content. So anyone who's attended Intro to C# with me knows that we cover programming principles and we happen to use C# as our language, okay? The principles that we learn can be applied to many languages like Java or JavaScript or C++. Okay, object-oriented programming is very similar. Object-oriented programming does not equal C#, okay? Object-oriented programming and object-oriented principles apply in many different languages, okay? I think the main difference here is in Intro to Programming C#, we learned how to write code. And at object-oriented programming, we're going to learn how to model code after real life. And I hope here in a few minutes that will make sense to you. But a conversation I always have when teaching Intro to C# is, well, how can I apply loofs to the real world, right? How can I make if statements meaningful in my job? Okay, and this is how we do it, through object-oriented programming. We create objects and classes that model business processes or real life, like signing up for movie night, for example, and those make our programs run. So let's dive right into object-oriented programming. Okay, the first concept you need to be familiar with is a class. Okay, if you did Intro to C#, you know that we just kind of typed class because I told you to. And you need to know that you can create many classes, and a class is really just like an abstract idea. It's a template, it's a concept. It's not something that you can hold in your hands in the real world, okay? For example, dog is a class, okay? Show me a dog. Don't show me a golden retriever. Don't show me your poodle named Skittles. Show me a generic dog. You can't do it, okay? The concept of dog is a template. It's a idea. It's an abstract thing from which we can model real life concrete objects, okay? So if the class is car, an object is my Ford F-150 with VIN number blah, 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 okay? Car is the abstract idea. Ben's Ford F-150 with VIN number blah, 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 blah is a thing that we can touch and heft, I guess, okay? So a class is a template. Here's an example of class in C#, okay? So I have here, I use the class keyword, and you can see that highlighted in blue. And then classes always have a name, and class names need to be unique. Okay, so I've created a motorcycle class. Again, just like dog, you can't just have a motorcycle. You can have a motorcycle that's a Kawasaki, I don't know motorcycles, X5109er, and it's parked in my garage, right? That's a real motorcycle. This motorcycle that we're dealing with is an idea or a template of motorcycle, okay? You can see the word class, you can see the word motorcycle. And just like functions or if statements or loops, classes are contained within curly braces. So you can see directly after the class and motorcycle keyword an opening curly brace, and then down at the very bottom of the slide, you can see a matching closing curly brace. So anything that is inside the class should be contained by curly braces, okay? A class is where we define things that are true about all of the objects of that type. So all motorcycles have two wheels, right? All motorcycles will have a weight or a color, and all motorcycles should accelerate or brake. Okay, here is another example of a class. There are thermostats. Think of the thermostat in your grandparents' house, okay? It was probably, it had a needle and a dial, and as you moved the dial, the needle went up or down, okay? Now think of the thermostat you may have in your home. It may be a Nest thermostat with a digital display, and to turn the temperature up or down, you hit a touch screen button, okay? Thermostat is the generic idea of a controller for your furnace with functions like turn the temperature up and turn the temperature down, or tell me the current temperature. That is a class. It's just a generic idea from which we can create concrete things, okay? So let's talk about objects. We've said a couple different times now that you create objects from classes, okay? If a class is a pickup truck, the object is Ben's blue Ford F-150, okay? It's a specific concrete thing that you can touch. So here is an example of C# creating objects. You can see here that there are a couple things you need to do when creating an object from a class. First off, remember our class was called motorcycle. I'm referring to that same name here when creating a variable. Instead of saying int or string like we did in Intro to C#, I'm using my new data type called motorcycle. So I say motorcycle, And then Sherry is the name of my variable. It's the name of my object, right? I use the new keyword because we are reserving space in memory. And then I say, give me a new motorcycle with opening and closing parentheses. And we'll talk about what those parentheses mean later on. Okay, but this is how you create an object. This is how you create a concrete, actual, touchable thing from an abstract idea. You can see here that we're filling in the details of Sherry the motorcycle. The weight is 900 pounds, the color is blue, and it's got a VIN number. And immediately we make it accelerate, and then we make it brake 3 times each, okay? So Sherry the motorcycle is a concrete thing. It could be sitting out in the parking lot. It's an object. But a class is an idea. It's the template for all of the motorcycles that have ever existed, okay? It's not a concrete thing. We create concrete things from the abstract idea. Okay, here is another example of creating objects. So you can see here that I am creating an object called Ben's nest. It's from a thermostat, right? So this is the nest hanging up in my wall in my imaginary house because I'm not fancy enough to have a nest thermostat. Okay, here's a thing that I can actually reach out and touch, and I call functions on it, which they're not functions. We'll talk about what they are here in a minute. But I can do things to this object. I can't reach out and touch classes. Okay, so in summary, an object whole is a concrete thing. A class is an abstract thing. It's an idea, okay? Objects do a couple different things. They have behavior. So these are the things that they do. If we're modeling the person object, some of the behavior would be walk or talk or kick, right? Or if you're one of my kids, spit, okay? And objects also have data. So things about their state. For example, the person class, again, they may have a state called is asleep, right? That's some data about the person. Are they asleep or not? Weight, height, eye color, hair color, and eye color, all right? So objects have behavior and data, right? The classes are the templates that say every object that is a motorcycle must have a weight and a VIN number. But an object says the specific weight of this concrete thing is 900 and the VIN number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? For example, think of the fish Flounder on The Little Mermaid. He was yellow, he had blue stripes, and Ariel could reach out and pat his little head. I don't know. He was all head. All right? So Flounder was an object. He was 5 years old. He had a tuft of hair on his head, and some of the things he did was swim and nag Ariel and freak out, okay? Flounder was an object. Fish is the type of object he was, or the class of object that he was. Okay, classes and objects have several different components. They have things in them. So how do we get behavior and data into classes and objects, okay? There are a couple ways we can get data in and a couple ways we can get behavior in, okay? So the very first thing you need to know about a class is that it can have a class level variable or field, okay? So these are things that hold data. They're very similar to variables. They have a name, they have a type, and they have a visibility level, but we will ignore that for now. For now, just make everything public, okay? So the class level variables need to be inside the curly brackets of the class. Remember, a class has a body, and the body is between an opening and a curly bracket. You should know that the order of level or class level variables is not important. And a coding standard that we have here at Health Equity is if it's a class level variable, it should not be capitalized. But this is not a requirement. So let's look at an example here, okay? We have the fish class, and here we have 3 class level variables, okay? Can you pick out what they are without me telling you? There are 3, okay? They are name, age, and color. So you can see over here that these class level variables look very similar to the variables that we declared in Intro to C#. They've got names, name, age, then color. They've got types, string name, int age, and string color. Again, just put everything, make everything public at this point. We will learn what that means very soon, okay? So these are ways we can model, or we can have data inside of our classes and objects. You can see on the left the definition of the class, and on the right you've got the several objects being created, okay? So we've got one named Flounder and one named Nemo. There are a couple different ways to create objects, and I will go over that more when we do practice. But just know at this point that class level variables or fields hold data. Okay, a property also allows us to hold data, okay, except for these data holders, for lack of a better term, have special methods called getters and setters, okay? And these allow us to make certain things happen when we get the variables or when we refer to them, and when we set them or when we give them a value, okay? Again, class level properties need to be defined within the curly brackets of the class, and class level properties should be capitalized. So let's take a look at our slightly refactored fish class here. You can see name, age, and color again, string name, int age, string color. Those didn't change, but you can see after each of the properties an opening and closing curly brace, and a get and a set, okay? And this is just shorthand. This is almost exactly identical to the fields that we had before. You just see that we have instead a get and a set, and there's really no reason to have the get and the set in this scenario. But if I wanted to make something else happen when the name variable was referred to, I could do that with the get method. And again, we will see some examples of this very soon. So you may be asking, what is the difference? We will be able to cover those here in a minute when we are practicing, but just know that the shorthand answer is when you want something else to happen, when you get or set variables, use a property. When you don't care, when you just want data, use a field. Okay, here we go. Here is an example. So you can see here that this is the old style before properties in C# of how we would do this. You have an internal or a private property called _color, and then you have a setter and a getter in the fish. So you have a set color method and a get color method in the fish class. Okay, these two things are completely identical, but one is one line of code and the other is like, what, 10, 12 lines of code. So C# gives us this shorthand method here as a replacement for this. Okay, here is one reason why you would want to use a getter or a setter. For example, anyone, well, I'm not going to cover that right now. Here, anytime anyone refers to the color variable, we're going to take the color and make it all uppercase, right? So this is an example of when I'd want to use a property. When someone refers to color, the color always needs to be in capital letters, okay? There's one reason why you'd want to use a getter or a setter. Okay, that is how you store data in classes. But now it's time to talk about how we store behavior in classes, okay? Objects have behavior. Humans walk and talk. Dogs bark, okay? And you'll see that methods are very similar to functions, okay? In fact, they're almost identical. They just have that public keyword in front of them. Again, we're not going to talk about access modifiers today. Just make everything public. Location or order within the class is not important, but again, it needs to be inside the curly brackets of the class. So without me telling you, what are the methods inside of the fish class? There are two. Okay, and they are sing a song and swim. Just like a function, you can see that they have a name, they have a parameter list, and they have a return type and a body, okay? The difference is they are contained within a class and they have an access modifier. Constructor is a special kind of method that says when someone uses the new keyword to create a new object from a class, I want certain things to happen. Okay, there can be multiple constructors, but they look like this. You can see here that a constructor is almost exactly like a method with a few differences. A constructor has to have the same name as the class, and it does not have a return type because the return type is an object of type fish. So we don't need to define that again, okay? This constructor says anytime anyone wants to create a fish, they need to specify the color, okay? You can't create a fish without telling me what color you want it to be. So over here on the right, you can see that we are creating a fish that is black, orange, and white. And then we specify that when saying new fish, okay? This is calling our constructor method. And then after we've created the object, we can go and set name and age, the public fields on our class. Okay, so a constructor, again, is a method that we use to create objects. And you can have multiple constructors. You could have a constructor that requires that a color be specified. You could have a constructor that requires that a color and a name are specified. Lots of constructors could be created. As I had on the slide, constructor overloading is something we will cover in the future. Okay, here is another example of constructors. Okay, you can see here that there are two constructors in the fish class. One says, when you create a fish, you don't have to specify anything, or when you create a fish, you have to specify a color, and we're going to specify that the age is always 1. And then over here on the right, I'm calling the constructor with no arguments, calling this constructor, and then I'm calling this constructor with arguments, okay? So here is an illustration of how you can have 2 or more constructors with different requirements. These are basically different ways to create a fish object. So let's do some practice. I've done a lot of talking, and now I'd like to crack open Visual Studio Code, and let's create some classes and some objects, okay? First off, we're going to create a dog class. For those pet lovers of you watching, what are some things about dogs, right? Think about those as we go through and create our classes. So I'm going to pop open Visual Studio Code here. All right, and I am going to create a new C# file. All right, it's not a requirement that each class be in its own file, but it's probably a good idea. So let's remember, when we create a class, there are a couple things we need to do. First off, we're always just going to use the public keyword, okay? That's just something we're going to do, and trust me until we talk about access modifiers. The next thing we need to do is use the class keyword, okay? This is a reserved word in C#. We always need to use it and always needs to be lowercase. And then after we use the class keyword, we want to specify our own unique class name. So I'm going to do dog. Classes have a body. The body is between an opening and a closing curly brace, okay? So I'm going to make a couple sections here. Data and behavior. All right, what are some things about dogs? What is the data that a dog has? So first, I think that we're going to make everything public. All dogs have a name. Okay, easy enough. We've created our first class and we've added our first property. It's a string property. Actually, this is a class level variable or field, and it has a name, okay? Let's create some more data about this dog. Public, maybe int weight. How about that, okay? I want to create this as a property though, so that I can show you just exactly why we would ever use a property. When we create a property, like I said, we can make specific things happen when the property is referred to or when the property is gotten. All right, I've got that all nicely formatted now. And I'll create a field. Okay, when someone tells me what the weight of the dog is, I want to do a little bit of validation, right? Does it make any sense for a dog to weigh -1 pounds? No, it doesn't, right? So I want to make sure that anytime anyone tells me what the weight of a dog is, that the number is greater than 0. Okay, value is a special keyword. That means when someone sets or says weight is equal to a value, the value keyword is what they're trying to set it to. So I can say if value is greater than 0, then we want to assign that value to our weight class level field. Okay? Otherwise, if it's negative, we just want to make weight 0. And I think this model's real life because no dog can weigh less than 0 pounds. Does that sound right to everyone? Okay, when people get the weight, they should get this little class level field here. Okay, so this is one reason why you might want to use a property instead of a field, right? I can make certain things happen anytime anyone gets the weight or tries to set the weight. If I wanted to be really funny, I could always say every time someone asks what the dog's weight is, I could say, well, since you asked, he just gained a pound. Right? Could do that. Okay, for now, let's just stick with this as a field. Okay, another thing is every dog's bark sounds a little bit different, right? So we want to say, give me what the dog sounds like when it barks, okay? So now we've got some of the data about a dog, obviously not all of the data, but now we want to do some behavior, and we want to model behavior with methods, okay? So methods are like functions. Once again, just trust me, we're gonna make everything public. Then we want to give it a return type, string, and then what is the name of the behavior that the dog does? So a dog barks, right? So when we created the dog, we said, what is its bark sound, okay? When the dog barks, it's just going to return the bark sound. Here is a very basic dog class, all right? This is not a real dog. This is not my golden doodle named Gus. This is an abstract idea of dog. You can't pet this dog, okay? Let's go create a dog that you can pet. So I'm in here in our main function, and I'm going to clean up this old program. And I'm not going to delete too many curly braces. Okay, now I should be able to create some dog objects. So remember, when we create objects, we have to refer to the type of the object by its name, and then we give the dog object a name just like a variable. So I'm going to call him Spida. We say assign a value to this, and we assign a new value. We say create a dog in memory. We refer to the dog again, open close parentheses. All right, now we've got a dog. Now we can start filling in the data about this dog. So this dog has a bark sound that sounds like woof, woof. Okay, Spida also has a name, and we're going to call him D. Mitch. Okay, and Spida has a weight, which is 100 who knows what. Okay, here is a dog that you can actually reach out and touch in the programming world, right? This is a concrete dog. It can do things. It has data. All right, so let's go ahead and write out to the console Spida's bark sound. And just like calling a function, I refer to the actual concrete object here, and then I do a dot, and then I refer to the function or method name. Okay, this returns us a string, and then that string will be written out to the console. Okay, and as you remember, .NET run is the command we use to run our console applications. I had to pause to remember that, sorry. So I'll run that, and you'll see here that written out to the console is woof woof. Okay, that's because Spida, our dog that we can reach out and touch, has a bark sound of woof woof. Okay, that was practice number 1. Practice number 2 says let's create a health savings account class so that we can create many new HSAs and increase Health Equity's stock price. So let's do that. I'm going to come here again, and I'm going to create a new file, and I'm going to call it health savings account.cs because it's a C# file. Okay, I'm going to come here again, and let's create a class. So public, because you guys trust me, class is the keyword for creating a new class, and then we want to give it a unique name. We cannot call it dog again, because as you can see, dog is already contained in this program, basically. I can't have another class named dog. When I say new dog, the computer doesn't know which one to create. So this is a new health savings account. So what is the data in a health savings account, and what is the behavior? Right, so some of the things that we track here at Health Equity are like the opening date, right? Public string opening date. And actually something that we need to start using is a date time. That is a specific type of, we're going to create an object from a class, so a date time models a date and time. Pretty intuitive there, right? So we want to know if the account is active or not. Maybe we want to know the balance. Right, there are so many things about a health savings account that we could capture in a health savings account class. Fine. Okay, so what are some things that you can do with a health savings account, right? I think all of our favorite thing to do is to deposit money into our health savings account. So let's create a method called public void deposit. Now, when we deposit money into the health savings account, what should happen? Well, first off, you should tell us how much money is being deposited. And when we take that money to Health Equity to deposit the amount, you would hope that Health Equity stores the balance or the new deposit amount in our balance. So we will say balance. Okay, there we go, some behavior. The deposit amount is added to our balance. Our least favorite thing to do is to take money out of our health savings account, right? So we want to withdraw. And just the opposite of balance, we probably want to subtract the balance amount, and we need to reduce the balance. Okay, so some interesting, this is why object-oriented programming is so powerful. We want to model health savings account, and we want to put all the rules for a health savings account into one place so we don't have to remember those rules in all the different parts of our program. So it just so happens that we have deposit limits on our health savings accounts here at Health Equity, right? So we want to make sure that nobody's health savings account balance goes above a certain amount, right? So let's create another method here. And we want to take in how much money they want to deposit. Okay, and let's say if the current balance plus the deposit amount is greater than 6,500, we want to return true. Otherwise, we want to return false. Okay? So we only want to allow this deposit to happen if it's not above the threshold. So we will say if is above threshold, deposit amount, and don't do anything else, go ahead and deposit the amount. Okay, and maybe at this point we want to do like a list of account messages, right? So we might say something like public string account messages. Okay, when they try and deposit an amount that's over the threshold, we will add something to their account messages. Okay, so here we have a class. There are a couple issues with our class because we are using an array and we're never saying new array. We're never setting the opening date. So this is somewhere where we would want to use the constructor, okay? So let's make sure that certain things happen when an HSA account is created, or a health savings account, pardon me. So when we're creating a constructor, we're just going to use the public keyword, and we don't have a return type. This is a special kind of method. The name of this method needs to match the name of the class. Okay? So there are certain things we want to have happen when a health savings account is created. They need to specify the opening date. Okay, when they do that, we want to make sure and say opening date is equal to what they specified. And we want to make sure and initialize our array. And we're going to give them a capacity of 100 messages. Okay? So now let's go pop back over here to our program so that we can create a couple different health savings accounts. So this time I'm going to use implicit variable declaration. Remember, we can imply what type of variable we are from the right-hand side of the assignment operator. And we're going to call this Ben's HSA. We use the new keyword, health savings account, open close parentheses, and semicolon. But now we're getting yelled at because it says there is no argument given that responds to the required formal parameter opening date. So it's saying you didn't tell me the date that you opened this health savings account. Okay, so it's going to be 1/1/2014. Okay, now we want to start depositing some funds. All right, I got paid. Oh, my kid broke his arm. I'm cheating the IRS. Okay, and that obviously is going to trigger our code to disallow that deposit. So now I just want to do a console.write line, the balance. Okay, and can you predict what my balance will be? Let's boogie. $500, okay? If I were to also look in the account messages, I would see that I can't deposit $10,000. So here is an object. Here's a thing that we know exists for realsies, Ben's HSA. Let's use our HSA class to create more objects. Okay, I can just go ahead and create all kinds of objects. I don't know what happened. I'm sorry. Okay, well, let's keep going. So there's our practice, okay? I want you now to practice, right? I'm going to cast a spell here and turn you all into Culture Club members, okay? You are in charge of the next movie night, and you need to write an app to help us sign folks up, okay? So there are several objects or classes that we'll need to model here. For example, we need to model a theater. A theater has behavior and data, right? Like how many seats are in a theater? What are the seat locations, right? RSVPs. People need to tell us, I'm attending, my name is this, I need this many tickets, right? And people often say, I reserved this, but now I need more tickets, or I reserved this and I need less tickets, right? So there's some behavior for you. The Culture Club needs to make a ticket assignment. So what classes and objects would you create? Okay, I would like you, after you watch this video, to take some time to create 2 to 3 classes to model the various parts of movie nights. Maybe you could do theater, or maybe you could do a ticket assignment, or a team member, or something, okay? Just create a few basic classes with behavior and data, and then I want you to create a console application that creates 2 objects for each of the classes that you create. Send us this code. We need your code because the Thursday class will be based entirely off of the code that you send us. We will provide feedback and show some successes and some failures. So please take some time to write some code, send it to us, and we will chat more on Thursday. Please reach out to us once for the 4th time. Please be active on Teams, ask questions, come see us. We're here to help and to teach.